So, to avoid a global outbreak, epidemic, you want to keep people where they're where they are with their contagion until they're healthy, or until the medic or somebody can come and cure their disease before they move on. No, but the doctor doesn't get sick.
No, but some doctor from Nebraska last year flew to Africa into this village where there was a bunch of people that had Ebola, and then he caught it, but then he flew back to Nebraska without knowing he had it.
That happens a lot. And that's not good. I'm not discounting that happening, but he should have been smarter. And actually, he didn't necessarily have to get sick to spread it. That's the crazy thing. You could have germs on you, in you, that don't infect you, and you could still infect somebody else. But I just wanted to sneak in some talk about Pandemic because it's an awesome game. If you haven't come to Game Club and you've been thinking about it, a Friday is a great day to try it out because Friday is longer lunch, so come to Game Club if you want. But aside from that, you need graph paper and a ruler. Hazel? We have two of them over there. Yeah. We'll play Pandemic today. Alina? Hey! Ladies and gentlemen, I'm trying to hear Alina from the back of the room and I cannot. Alina. Equations, using equations make predictions. You could also just say equations and predictions. Spaceship. Whenever I feel the vibration of the machinery, I just feel like we're on a spaceship. Because think about it, if you were on a spaceship, even though you're in space, there'd be all these jets and things pushing you where you want to. There'd be a lot of vibration, a lot of stuff happening. All these movies that make spaceships seem silent and still. There'd be artificial gravity probably, but there'd be a lot of noise and stuff happening.
Well, yeah, but if you're outside in space, you wouldn't be able to hear it.
Well, yeah, but if you're outside in space and you don't have a spacesuit on, you're dead.
Yeah.
I mean, come on, we learned
takes
that
30 seconds to die.
Yeah, so you can get your cool pose.
Yeah.
All right, so Ariel is going to compete in Peloton, or more so, just join and ride. Who knows what Peloton is? Avi, what's Peloton?
It's like a bike race for, I don't know what causes it's for though.
Cancer research. Yep. Yeah. So there are all kinds of different fundraisers for cancer research. One of the biggest in Ohio is Peloton, and most of our giant corporations around here have teams that ride in Peloton and everything else. One of these shorter distances that you can ride is 30 miles. So Ariel is preparing to ride 30 miles, which if you've never ridden a long distance bike ride, not only is it oh, can I ride that far? And you're oh, well, you're sitting down and your legs just have to keep moving. Sure, I can ride 30 miles, but you gotta last. You have to drink enough water, you have to eat enough food. Your body has to be able to keep going. So you gotta train, right? So Ariel's been training all through February and March. She's been training. So when we think about what a box plot, scatter plot, histogram, what would be more useful, or what graph would be most useful here? What do you think? Turn to your neighbor and tell them, what do you think we would use for this table of data? Turn to your neighbor. Then I will random card. Elena, what do you think? Box plot, scatter plot, histogram?
Scatter plot. I have a book and I have
Elena.
But I would pick that anyway.
Fine, Elena, you get another question then. What depends on what here? Does date depend on distance?
No.
No, that would be silly.
Distance depends on time.
Distance depends on time. So, if I say I'm going to ride my bike for 30 minutes, that means I've gone 3 miles?
No. Because it's not going enough.
If your speed is,
I agree.
Or my
I
own
agree
10
if
minutes.
your speed, but you can't say an if. You're saying distance is dependent on time. And I don't disagree. This is a hard question, guys. In this situation, what depends on what? That's a hard question. Liam, do we have a Liam today? I don't think I've seen Liam.
Norbert.
Norbert, what a weird day. Patrick, what do you think? What depends on what here?
I feel like distance depends on a mixture of what day it is and how much time it took.
Okay, distance depends on.
Cause like the day is like the farther, the more days it's been, the more days she's practicing. So she'd be getting faster. Hopefully.
I would agree with you, except cycling isn't really like one of those things. Like, you can only ride so fast. And actually, the point of this isn't to be the first person across the finish line, it's just to finish. Like, you can make it a competition, but really you're competing against yourself. There is no, like, award for first place. Now, there's bragging rights, right? You're like, aha, I finished first. But she's just trying to train to ride at a constant pace, so she's not changing her speed. Here, and this is why I asked this question, we are actually going to create a graph different than what we're used to. We are going to create a graph that has time on the y-axis. Because how long your ride takes depends on how far you chose to go. So while time does go on its own, we're not talking about time of day or time of, like, we're talking about length of the ride, essentially. Like, length in time, length in distance. So time depends on distance. So please set up in your notes an x and a y-axis where time depends on distance. We're not going to use a ton of our page. We're going to spread out our data to make life easy for us.
How big should it?
A 10 by 10 is bigger than you need. Like, what I've drawn is bigger than what we need. Because we're going to scale it. We're going to scale things to make life easy.
Well, yeah.
You can make it whatever size you want. I don't care. But this is going to be smaller than a 10 by 10 up here. If distance are my x's, right? Because we said y depends on x, and here we're saying time depends on distance. Now, you could flip this graph. It would, like, that would be fine. But I just wanted to show you guys a situation where time depends on how far we went. Like, we've got some runners in here, right? Like some cross-country people. Yep. Like, when you talk about, oh, my time, you know your time depends on how far you went. When you say, oh, my run took 5 minutes, nobody's thinking like, oh, that's great, unless they know how far you went. Right? Time depends on distance. Whether your time was good or whether your time was bad depends on, well, what distance were you trying to go. So, Audrey, help me out here. Yao. What is our max x value we got to get to?
25.
25, right? So somewhere up here, we want 25. If I use all 10 boxes, I could scale at 2.5, or make your life easy, scale at 5. Don't even write the 2.5. Just make every 2 boxes 5. So we can go 5, and 10, and 15, and 20, and 25. You can do a different scale, I don't care. But it just will look different than mine. Henry, what's our Y max gonna be?
Our Y maximum is 150, so we should definitely scale it.
We should definitely scale it, because I don't want to use 150 boxes. If we want to use 10 boxes, what's an appropriate scale here?
1.5 per box, so 3 every 2 boxes.
1.5 per box?
15 per box.
15 per box. Be careful with that division. So, if we want to make our life easy, like Henry said, we could just go 2 boxes, and we could say 30, 60, 90, 120, 150.
Or you could do the heartbeat one, since we don't need we only need we only start at really 60.
35. There's no reason to break our graph here. So broken graphs are not nice because they mess up what our data looks like. We don't want to use broken graphs unless we have to. And actually, as we get into election season, guys, 2020 is an election year, broken graphs are a way to manipulate your data and trick people. So Simon, you're not a trickster, are you?
No.
He's a trickster!
So, plot your points. You don't need me. Plot your points. Plot your points. Plot your points. Crap. Well, because I wasn't touching my screen, but it registered. Yeah. Oh, sorry, I forgot that I didn't put this on your paper, so you need to be able to read what's up here. So I'm just trying to color code to help you guys see things. Was everything okay yesterday? Was the guest teacher cool?
Yeah. Cool dude.
He texted me the report from the day, so I assumed he was probably a younger person.
Yeah.
He's cool.
And then he texted me later and was like, if you ever need a sub again, just let me know. I was like, alright, so apparently he liked you guys. Because if people don't like where they subbed, they won't say, here's my email, let me know if you ever need another sub. They'll just say the day went fine. Like, they won't say, invite me back, please. So apparently he liked you.
That's good.
Then, actually, like, he specifically wrote about, there was this one kid.
There's always that one kid.
Then draw what you think is the line of best fit.
Does the line of best fit have to go with the origin or not?
You tell me.
No.
Is this situation? Well, okay, so that's a that's a really good question, though.
I'm gonna say no. Because you're talking about you can figure that out to figure out somewhat what the y-intercept is, so therefore it can't always be the origin.
Okay.
This one has
So the question really becomes, is this relationship proportional? Right? Because the line that goes through the origin is proportional.
You can't be like, you can't go in 0 minutes, like 2 miles.
So let me change this situation. Not really change it, but so when I go on a bike ride, no joke, like I'm not making stuff up, I'm being true here. Okay, there's one part of this where I'm gonna lie to you. It's not a big lie. So I have a mount for my handlebars that my phone goes on, but once it's mounted, I can't really use it very well because it's like secured and it's like not going anywhere. So these rides that Ariel's been taking, she puts her phone on her handlebars, hits like ride, and then she puts on her clip-ons because you wear special shoes when you're a cyclist, and then she like stretches, right? You gotta like, do the whole thing, and then she gets on her bike and rides. So if she already hit start ride and then does all that stuff, and we draw a line of best fit that doesn't look like it goes through the origin, then what, critical thinking here, what is this telling us? And Alex, I'm coming to you since you brought this up.
That's the amount of time spent not riding.
Yeah. The amount of time spent not riding. Or the amount of time through her ride that she eventually wasted on, maybe she stopped in the middle of her ride. Because remember, this is end data. This is at the end of the ride. So maybe every ride, she stops to get ice cream. Because berry's good for you when you're working out. Maybe in the middle of her ride, she stops for ice cream, and it's like a 25-minute break. Right? Like, who knows? But if this doesn't go through the origin, what that tells us is there's time that did not get distance. Once you have that line, try to predict the equation that would match it.
Well, what if I did a line that came from the origin?
Sure, okay. So you're just going to have a slightly different equation. That's fine. Line of best fight. So if you're using your line of best fit to try to find the slope, it's nice to find two, what do we call these points? Lattice points. Thank you for those of you that have been awake while we learn these things. So if I look at rise and run here, 15, 30, 45, 60, 5, 10, 15, 20, 25. I'll reduce this in a minute. And then my y-intercept, actually we can go ahead and erase b and put in a y-intercept. 15, if I approximate maybe like 20.
But Mr. Hudson, there was never a point at 60. Oh, never mind.
That's rise versus run. Rise versus run. Do you need graph paper or do you have some? You really don't need a ruler. I'll grab you one of my broken ones. We're not measuring, we're just drawing straight lines. Then, Ariel really wants to use this to determine how long we think it'll take her to ride 30 miles. So, hold up, give me your eyes, pencils down for a second. If we have an equation, and I don't care what equation you have written down, you could match mine, you could not match mine, I don't care. Is the distance she is going to ride the x or the y? X. And here's why we set up our graph and our situation like we did. Now I can plug my 30 into my x and easily get my value. If we had made our graph the other way around, using time as our x-axis, we could, but then the distance she's gonna ride would be our y, right? So be careful how you set up your graph and how you write the equation to match. That determines what this will be. This could be a y if you set things up differently. Does that make sense? We built this. We chose x and y. So that's why our 30 is our x. Does that make sense? Do we have any questions on that? I have seen people get confused about this on the mastery assessments. That's why I'm going over it.
I didn't really get what you said.
So because we built our graph, thank you for asking, because I bet like at least 5 people were confused just not asking. We chose distance to be our x-axis and time to be our y-axis because we said time was going to depend on how far we rode. We could have, in an alternative universe,
Done it the other way around.
or alternative timeline, done distance compared to time. But what that means, we could have done time. See, I'm stuck on what I'm trying to do here. We could have done time down here like we're used to, and distance up here, but then our equation would be distance equals m times time plus b, whereas up here we have time is equal to, we could reduce this to 12/5 times the distance value, right, plus our so it all comes down to how you set it up. What I'm telling you is your equation could be totally flipped around from mine, and it would still be right. What I'm trying to get you to realize is there's multiple right ways to do this. And the reason why I'm being so cautious about this is the next problem I'm going to show you, I'm going to have you do totally on your own. And we might have 2 different directions that the class goes. That's okay. Please don't bend that till it breaks. I'm running out of rulers because they don't come back and people break them and throw them away. Simon?
Would it be 60? Because so there are 5 squares, but I thought that the thing was that it was
Oh, Snapple. You're absolutely right.
Oh yeah, that's what.
That's only 12 point. My slope is wrong. If you guys blindly trusted me, this is wrong.
Yeah, that's what I.
This is actually 12.5. So this is actually, I'm going to do 24 because this is actually not 25. This is 12.5. Or I would have chosen a nicer point. I could have gone all the way up to here and gotten kind of a nicer one. So this is really 24/5 as my slope. Instead of 12/5, we can make it 24/5. 4.8x. So if we write this out nicely in decimal form, y equals 4.8x plus a wasted 20 minutes. Not really wasted. Stretching is important. 4.8 times 30 plus 20. 5 times 30 would be 150. So this is going to be around 170, a little less. Anyone have it?
Wait,
If this was 5, this would be 150.
but it's less.
I know, it's less. So it'll be 160 something, probably. Did you calculate it?
Wouldn't it be 4.8 times 30 would have to be 144, right?
Yeah, there you go. Well, you did 48 times, yeah, and then plus.
The 20 would be.
Yeah, 164. I was looking for the final number. Sorry, I wasn't ever saying the answer was 16.
Oh, okay.
The answer is 100. But so you said that 5 times 30 is 150.
Would be.
Yeah. So then is 4.8 less than?
Yeah, but then plus 20.
Ah, right.
And what's the label on this? Minutes. So it's going to take her almost 3 hours to ride that far. Which I have a friend that does Peloton every year, and she's done the 120-miler. You ride all day long. Like, you are on that bike all day long. In the back of your shirt, in the pouches, which these shirts look really funny because they have pockets on the back, but you're pulling out like packets of goo, and you're like eating, like it's like sugar and carbohydrates and yeah.
So they can just reach back there, so
Yeah.
so don't have to stop and eat.
It's go goo, essentially. Is
I have a pocket.
yeah. I mean, they have different flavors of stuff.
I have a pocket.
I normally do like granola bars. I'll like have like a broken up granola bar and just grab chunks of it. All right, try this on your own. This data. So the first thing you're going to ask yourself is, does distance depend on heart rate, or would heart rate change depend on distance range? So read the situation, set up an XY axes, label them, scale them, graph the points, graph a line best fit. You guys know what you're supposed to do. Well, it's all up there. So.
How is the negative heart rate a gain?
Change. So remember, read the situation. Did you read that whole paragraph there? So just to give you a little bit of help, if this is a study done by a health organization, like an insurance type study, do they want the run dependent on a change that happened to your heart, or the change that happened to your heart dependent on the run? Yeah, you want the heart change to depend on if they ran or not. Because what they set up as the independent variables, did we run? Well, yeah, my independent variables, did I run or not? That choice is independent. But the heart change is dependent on did we run. So when we go to set this up, remember y depends on x. Y depends on x. I decided while I stood there that I wanted all of our graphs to at least look the same. Y depends on x. You don't have to redraw this one because it's just practice.
Oh.
We do have a couple negative results.
I do.
So notice they want your heart rate to go down. A lower resting heart rate is healthier. It's easier for your heart. So the negative means their resting heart rate actually went up. All of that is said to you in that paragraph you were supposed to read. No. So we're still going to call, so positive 6 is going to be up 6. But what that actually means is 6 heartbeats per minute came off of their heart rate. But we still call that data positive because it's good. It's what we want to happen. A 1-by-1 scale would probably work here, right? We go up to a maximum of 8 on both sides. We only go down to -2, so a 1-by-1 scale would not be bad. Our 2 results that end up in the negative are down here, and this one is close to our line, but when we go to do our line of best fit, we're going to notice it doesn't quite fit. So heart rate should be up your y. Distance should be across your x. Not necessarily. So, thank you for asking that question. If we try to draw a line of best fit here, this negative point is pretty close, but this negative point totally is not. What do we call a point that when we draw a line of best fit just doesn't seem to fit? Just shout it out. Outlier. Now, do we have to include the outlier in our line of best fit? No, we just say, hey, you don't match. We don't know what happened. Maybe this person who ran like 7 miles that week also decided to pick up smoking. And that's really bad for your heart. So this is actually bad. This is the opposite of what they want. Someone who ran had their heart rate actually speed up. What's weird about this graph, guys, is the points up here mean that their heart rate slowed down, which is good. You want your heart rate to slow down. Like, that's easier for your heart. Pump less times. This person actually had their heart rate speed up. And we're not talking about while they're running. We're talking about resting. So, what, though, the bigger thing we want to talk about here, what's the association that we see if we ignore the outlier? What's the association that we see here? Positive. Is it strong or weak? If we ignore the outlier. What do you think?
say it's pretty strong.
Pretty strong. All my points are pretty darn close to the line. Spread's not that far. I'd say it's moderate to strong. Like we can always say moderate. If we don't want to say weak, we can say moderate. Yeah, I'd say like moderate to strong positive association with at least one outlier.
2.
Yeah, maybe 2, depending on how we count that. So then if we go to try to make a equation to match this, go ahead and try to make your equation and use that to predict for an employee who ran 10 miles. Henry?
For my line of best fit, I actually got a 1-to-1 ratio.
Really?
Yes. I included .1 -2 though.
So this point is more so on your line, or at least closer?
Yeah.
If I use the line here, because I kind of took the cheater's way out and used what the book kind of suggested. Oh crap, that's eraser. Sometimes that point or this point are really convenient, because one of your values is 0. Right? So whether I use the x-intercept or the y-intercept, a lot of times those are convenient for us. And actually, especially if you're working on graph paper, sometimes you just kind of draw lines and say, well, what works nicely? If I go from 8, that goes down to like, I don't know, 6.5. If I go from 6, this goes up to, I don't know, almost, yeah, that's pretty close. 6, 7. So if this is from -2 up to 7, it'd be 9. Oh, that's kind of weird. This goes over about 6. My slope apparently is 3/2, or about 1.5. So my line's just a little bit steeper than yours, Henry. Not right or wrong, just mine's a little steeper.
Mine, I got the same as you.
So then if we try to make an equation, y equals 1.5x minus 2. Not 20. Sorry, so then my brain is trying to think about the 10 they gave us. If 10 is how many miles they ran, is that our x or our y? Henry?
Oh, is it okay if I keep my line of best
Sure.
fit?
Yeah,
for the
totally
equation?
fine. Yep.
Okay.
That's why I said, yeah, just try it on your paper. This is just what I had to work with. Avi?
I got something like around 4/4, so like 4/4, which would be.
That's the same as Henry. Yeah, he got a slope of 1.
Okay.
Yeah. So your slope, it looks like some of our slopes are coming out to be like pretty close to 1. Hazel?
I got a slope of 5/3.
Yeah, that's closer to mine. Yeah, 5/3 is pretty close to mine. So you're fine.
As a decimal?
5/3. So think about, that'd be 1 2/3. That'd be 1.6. Whereas mine's 1.5. 1.66. But Katie Ann?
Mine's 4/3.
That's between 1 and 1.5. You're fine.
Like,
It's all.
1.5 is like, 1.3 is like a weird number.
So round it and just do 1, or just do 4/3. Leave it as 4/3. Simon?
I got 8/7.
That's just over 1. Guys, if you're anywhere between 1 and 1.5, you're fine. It just means you lined up your line a tiny bit different than what I did. It's okay. Patrick?
I got 2.
Then you just made it real steep. I think you probably tried to use this point. If I were to guess, you tried to use that point and like this point, or you just angled steeper. Or double check that you didn't count wrong. Like if you're worried that it's wrong, just double check your counting and everything. Avi?
With outliers and line of best fit, you just ignore them?
Yeah. Yep. That's why. So as soon as we decide this point is breaking my line of best fit, forget about it. It becomes an outlier. They're like, forget about it. Like that makes it an outlier. When you decide it's time to forget about that point. And we're out of time. So there we go. This is a cool thing for Math 2 that we were talking about. Work on your homework over the weekend, please. Turn in 724, 725 if you have not done so yet.